Regina?
Thank you very much, Mike, and we're ready to answer that question. What is happening? We are currently in Nyeri County, that is County 019, being hosted by none other than one of the very best institutions of learning in Africa when it comes to tech. We're talking about the Dedan Kimathi University. And this morning, Mike, we are talking about engineering at 60, looking at the strides that have been made in engineering and engineering for the future. In fact, the theme for this particular convention that we are at, which is the Engineering Partnerships Convention of 2024, it is themed Engineering at 60, that is reflections, response and resetting. And to take us through this conversation is none other than Professor Engineer Peter Nganga Mushiri. Thank you, sir, for your time.
Thank you.
You're the good host. We are enjoying your company. But then let's also look at the university in itself and the role that it's playing to build capacity when it comes to tech and innovation.
Thanks a lot, Regina, and I'm very happy to be joining your team today. And thank you for coming to Dedan Kimathi University of Technology, celebrating engineering at 60 years. And we are very happy as the university to host the engineering convention, because this is the home of technology, Dedan Kimathi University. And we are a home of technology because 92% of our programs are in STEM, and basically engineering is our biggest faculty. And we look at all the engineering because we believe in the power of engineering to bring transformation in this country. If you look at the infrastructure, you need civil engineering. You look at the electrical system, you need electrical and electronic engineers. We look at industrial system, we need mechanical engineers. We have mechatronics engineering, telecommunication engineering, and it is the technology that will bring transformation in this country and also create to the jobs of the future in our country.
No wonder the theme where we are doing reflections, responses and resettling. Now, you've mentioned that in your courses, your 90+% STEM. Was this deliberate, and what impact is this going to have, in future? When you say future is going to be driven by tech, we are already in the tech. Was this deliberate, and what are you looking at?
Thank you, Regina. This is a very deliberate effort. We decided to stick to our core business as a university of technology. In Kenya, we have around 4 categories of universities: comprehensive universities, specialized universities, like these are specialized university of technology. And we decided from the beginning to stick to our core business because we believe in the power of technology in bringing national transformation and development in our country.
Now, Prof, if we look at the statistics currently, we are having very few actually students taking up STEM subjects. How do we address this?
This is a very important area because you find at secondary school, there are many students who struggle in mathematics and sciences generally. Like in engineering, you have to be very good in physics, you need to be very good in chemistry, you need to be very good in mathematics. And this is an area we need to address also as a country. We have to initiate a lot of interest in primary school, in secondary school, if we indeed have to boost the numbers that we require in our STEM subject and also in our tech programs.
Looking at the demographic, now that's where now we play the gender card. We are seeing that girls or female students are shying away from taking up STEM subjects. What do you think would be the issue, and how can we correct that?
That is a very important question, because if you look at the STEM subjects, actually look at mathematics, look at physics, the girls feel that maybe that's not their thing. They feel it's the boys who can shine better. But this is really an issue of perception, because I can assure you, Regina, the girls we have here doing engineering and tech programs are actually the ones getting the first class honors. Although they are less than 30%, and constitutionally you need to attract at least 30% gender parity for you to be compliant, we need to encourage more and more girls to join the STEM programs. Yes.
Now, as we're looking back, or rather reflecting at the strides that engineering has taken up, I'm seeing like 36% of the courses here are engineering out of your 90, or rather are based on engineering. What are the key projects that the university is currently running in this particular space?
Thank you. That is a very important question, because we as DeKUT, we realize that the way engineering can form a national transformation is turning engineering knowledge into innovation, innovation into startups and entrepreneurship. And what we are building is an innovation entrepreneurial university. A good example is Stanford University, the top university of engineering and technology in US. They started as Silicon Valley, which today is a major transformation. All the biggest companies were founded there. And like Stanford University, we have started DeKUT Science and Technology Park. And we are moving all the innovations, all the startups in the Science and Technology Park. And today we are hosting the biggest frontier technology, not only in Kenya, but also in the continent, semiconductor manufacturing at DeKUT Science and Technology Park.
Now that sounds interesting, and I'd want to take you back to, I think, a week where Deputy President Rigathi Gachagua was here to actually oversee that particular partnership that is going to help, or rather build capacity in semiconductor manufacturing. For those who are not techies or engineers, just unpack exactly what a semiconductor is and how will it transform tech.
Thank you. And I think it's very important to unpack this.
Yes.
Because semiconductor is the backbone technology for all the other technologies. If you open your phone, it is run by something we call a motherboard. And the motherboard is made of microchip and semiconductor. You need semiconductor in computers, in telecommunication, 5G technologies, artificial intelligence. Every technology is founded on microchip, because it is in the microchip you can be able to program, you can be able to control, you can be able to issue command. And it is the technology that forms the basis for all the other technology. A car today is more electronic than mechanical. You need semiconductor to run the car as much as you need semiconductor to run telecommunications, and it's the basis for all the other technologies. By entering into that space and having our students, graduate, know this technology, they are already entering into the deep tech that will define the world in the coming years.
I like that term, deep tech. So unpack for us also further the All Borana system, because this is the new kid on the block, so to speak. Yes.
Yeah, thanks a lot. DeKUT, we started some years ago building on the Science and Technology Park, which is an avenue for commercialization of technology. And our anchor client is Semiconductors Technologies Limited. And the All Boran system is where basically the microchip are produced. It is the first unit of its kind, not only in Kenya, but the whole continent.
Wow.
And this is a big statement that Kenya indeed can become an African hub of deep tech, and we can become like Taiwan. Taiwan today is the #1 leading microchip manufacturing country in the world, followed by Korea, South Korea, followed by Japan. China is also in that space. And in Africa, we have provided a leadership role in the deep tech production. So what we all need is the scaling up of that technology. We have proven beyond reasonable doubt that our engineers can be able to learn and develop that industry. We can develop innovations related with the semiconductor. We can do a lot of developments, and we can grow that industry because it has a big potential for creating jobs, creating wealth, and strategically positioning this country as a tech provider in the globe and in the world of the nations.
Deep tech changing the present and the future.
Yes.
Commercial viability, timelines. What are we looking at?
That is good because business has the timeline, and first of all, we have already started.
Wow, okay.
It is growing, and we are now in the process of setting up a major microfab plant that will scale up. Right now, the company has employed 100, and I'm happy that all the engineers running there are DeKUT graduates. And the scaling up is going to 1,500 with the total fabrication. And this is how we as a country can intervene in the supply chain. If you look at every product, there is a supply chain. Yes. The phone, you have to start with the microchip all the way to the final product. When we start with the deep tech required in that, we can be able to also create industries, expertise, knowledge, technology that can grow these industries. And in every supply chain, there is an industry. And so what we need as a University of Technology is to build capacity for providing human resource with the expertise that are required, and also the research technology, and then when we attract now the venture capital in this, we can be able to move the industry much further.
Now, who would be our major competitor in Africa? I say we are pioneers as Kenya,
Yes.
and rather I'm saying we because Dedan Kimathi University is Kenyan, but who are our main competitors within Africa in as far as this deep tech is concerned?
Well, we have countries like South Africa and Egypt who are also leading, but in the area of semiconductor manufacturing, we are the number one. And this is one area we want to be the leader. And we will not stop there because we can now go to artificial intelligence. It's very important we produce our own products because the other countries are producing AI solutions for their people. We need climate change technologies. We need 5G technologies. And we have to start from microchip so that we can build up on the other areas. Yes.
Now, what nano products, using nanotechnology, have you come up with so far as a university or as a unit?
Well, the semiconductor manufacturing, it's really, there is a lot of, there is a big value chain.
Okay.
Because you start with the material characterization, you go to microchip design, you go to nano fabrication of the microchip, the testing and validation of the system. So it's a big value chain. But the final output will be the microchip that are used for different commercial production. Yes.
So you foresee great demand for this product?
There is a big demand. Every component, every machinery, every electronic gadget, it relies on semiconductor. The market is huge. The potential is also very high. And also, it's the key component that you require for the production of all the other technologies.
Now, in the semiconductor manufacturing aspect, it's a private-public partnership, so to speak, that you signed some weeks back. In terms of building capacity, we've had the regulator actually, not on one occasion, working on saying that the Washington Accord, once it comes into implementation, it's going to allow local engineers practice even abroad and also open up this particular space, the local space for other engineers to come on board. From where you sit, is this a good direction? Is this
It is a good direction, yeah. Because what we have done as a proof of the concept that our engineers in this country can be able to design, develop, prototype, and manufacture in deep tech. And when we do that, it means that any other country, and especially the US, that requires specialized expertise in microelectronic engineering. And maybe to unpack this, right now, the current global economy on microchip runs around 680 billion USD.
Wow.
And in the next 10 years, it is expected to grow to around 5 trillion USD. And to grow that, you need more than 40,000 microelectronic engineers. So it's good, even as a country, we ask ourselves, how many of our engineers can become that percentage of the 40,000 that is required in the next 5 years? So as a University of Technology, we also want to be in the front line of producing these engineers so that they can also be competitive in the global space. Yes.
Now, what do you think is holding us back? Other than, especially looking at our education system, we've already looked at those who are already in this particular space. But yes, there's a problem. We're not having most of them who have taken up engineering, practicing engineering. They have studied engineering, but they're doing something else other than what they actually went to school for.
Yeah, Regina, this is a good question because what is important is opportunities. Opportunities. And that is why we need to produce more opportunities in the tech area, in the manufacturing, in the engineering field, because essentially people will go to where there are opportunities. If you do not have opportunities for engineers, they will look it up at the financial sector, the marketing sector, and other sectors. So by building a strong tech systems and growing the industry, growing technology in energy sector, we need engineers, and it is the growth of engineering sector that will provide opportunities for our graduate engineers so that they can practice and they can excel and help in building this country.
I like what you have said when it comes to artificial intelligence, and I've listened to different professionals across board. Some are worried that with the AI technology, they are going to be rendered redundant. But then I'm hearing in engineering, well, AI is actually good. Let's understand that.
Thanks a lot. Because what is very important, when every growth of one technology, there are some jobs that are killed, but it also creates other jobs and other opportunity. Let's talk about, for example, the area of automation. Initially, we never used to have mechatronics engineers who combines mechanical and electronic engineering to automate and to digitalize systems. So that's a new field, it's a new frontier of technology. And there are many solutions that will come in digitalization and automation of systems. So, and that is why as a University of Technology, we are training and building capacity in that. So the AI will change how the world and systems work. So we are also preparing our engineers. Can we enter into that space in designing and developing solutions in AI? Right now, we have a challenge with climate change. And even what we are currently experiencing in the country is a climate change problem. It's a global problem. And we need tech solutions that will address, mitigate, or pacify the effects of climate change. So that is a new frontier. We need investment in that, investment in terms of expertise, in terms of technology, so that we also become a frontier tech country that provides tech solutions in the area of climate change, among many other emerging technologies.
Engineering at 60, this is a theme for this particular convention that is based on engineering, reflections, responses, and resettling. You're an engineer.
Yes.
Yes. Do you think that this particular convention, the setup and the current situation we find ourselves in the country, as you've rightfully put, you're dealing with flooding, we're talking about our poor infrastructure, that this has come at the right time, maybe to give solutions on the engineering spectrum going forward?
Thanks a lot, Regina. Personally, I'm a registered professional engineer. I'm a mechanical engineer by profession. And engineering, even as it is today, it is the solution that the country needs. Every infrastructure you require, it needs to be designed by an engineer, built by an engineer, maintained by an engineer. And from energy systems, telecommunication systems, road infrastructure, housing solutions, and all the technologies that we have today and we will build tomorrow requires engineering. So when the engineers come together, we are looking at different thematic areas of how engineering interventions can grow this country and develop this country in the coming years. And I'm also very happy that this convention is coming to a University of Technology. This is the first time in the history of this country that this kind of a program has come to a university. And what a better university than the University of Technology. So bringing industry to the university and bringing university closer to the industry. Because what, Regina, we need in this country, we have relied so much on imported technologies extensively. And we need to build confidence that we have engineers that can design, that can develop, that can build our own technologies and also technologies for export. Because it is through engineering technology that we will be able to build jobs in this country, we will be able to build industry, and be able to create opportunities for wealth creation for national development.
Before coming on air, we posed to our audience among the issues that they'd want addressed. And one has come in and they're asking, who qualifies to join Dedan Kimathi University?
Thank you. That's a very good question. Because I said 92% of our programs are in tech areas. And tech, first of all, we get our students from COOPs. And these are students who have excelled in STEM subjects, very, very important. And essentially, like to join engineering, you really need to have a very good cluster point, 40 and above. That's very important. And then any other qualified student can come in as a self-sponsored student. And I'm very happy also to announce that we get 100% of all the students we require. So we do not have any redundant program. Our programs are very competitive, very attractive, and 100% of the declared capacity, we are able to attract the students. Yes.
Capacity, as we come to a close, capacity of the university in this particular courses?
Well, our total university capacity is 9,500 right now. And that's the population we have. Of course, the university will continue to grow because growth is very important because we have new emerging areas. And 82% of our students are in the tech program. You may ask, what about the other 18%?
Yes, where are they?
Who are they?
Who are they? Yes, who are they?
Engineering works with the business because every engineering innovation requires commercialization. Commercialization is all about business modeling. It's all about financial models. So the other 18% it's business.
Yes,
because when you connect engineering and business, that's how industries grow. And every industry in this Kenya is a business before it becomes an engineering enterprise. We want to connect engineering and business so that we can create innovation, technological, entrepreneurial ecosystems for our country.
I'll not try and water that down, Prof, but you have put it very correct. When we look at the solutions that we need, we make them commercial, and it becomes a business, right?
Yes.
In my layman understanding of
yes,
that conversation.
That is how engineering will have the business sense, because it is business that creates jobs, it is business that employs, it is business that creates wealth. And you look at all the tech countries in the world, look at Germany, look at Japan, look at US, it is the commercialization and engineering entrepreneurship that has created the bottom line economic development. That's what we aspire for this country, and that is what the University of Technology means for this country, Regina.
Indeed. And you've wrapped it up for us. We have been talking to none other than the Vice Chancellor of Dedan Kimathi University. Technology Hub that is hosting this year's edition of the Engineering Partnership Convention. And the theme is around reflections, response and resettling. That is Professor Engineer Peter Nganga Mushiri, and I'm Regina Manyara. We are keeping tabs here for the next 4 days or so to bring you up to speed with outcomes of this particular convention. Now back to you, studio. Mike, take it away.
Most definitely. Thank you so much, Regina, coming to you live from Nyeri County, where the Engineers Partnership Convention is happening. Right about now, Good Morning Kenya takes a short break. Don't go too far. We'll be right back with more.